So, I want to hear you celebrate just a little bit because here are your last set of trig formulas or trig identities. Nope, didn't hear anything. Oh, there we go. Okay, so, or I should say the last bit of trig formulas that you're going to get from me. These are called the sum to product formulas, or sometimes called the factoring formulas, because what we're doing is we're taking a sum of two things, or maybe difference, and we're turning it into a product. It's as if we factored it. This is pretty useful if, say, this is equal to 0, then we could set both of those equal to 0 by the zero product property and solve an equation. Okay, so look on the left-hand side of these things. Of course, we have a sum or a difference of either two sines or two cosines, always the same trig function. The right-hand side, for the sines, it's a sine and a cosine. For the difference, it switches cosine and sine. And think of those original sum and difference formulas. It's very, very similar to those. But for cosines, they stay together. We either have, where'd my marker go? There it is. Two cosines or negative two sines. Okay. Now, these whole formulas kind of look like the product to sum formulas, only backwards. And that is, in fact, what we have to use to prove the things. But it's a bit tricky. Speaking of tricks, here's the trick. What you want to do is you want to let x equal to u plus v and y equal to u minus v. Then you're going to add and subtract the x and the y and use the product to sum formulas. Sounds a bit complicated because it is. So see if you can follow me here. On exercise 13, we're going to prove the sum of the sine formulas that turns it into a product. So what we're going to do is initially, I can't even find my cursor here. Alright, let x equal u plus v, and that's an and sign, y equal to u minus v. So if I were to add x and y together, so x plus y equals, I'm going to just add these two things, u plus v plus u minus v. When I simplify that, my v's cancel out. So x plus y equals 2u. And u equals x plus y over 2. Okay. Let's also take the difference of those, x minus y. So I take the first one, u plus v, minus, put this in parentheses, the y value is u minus v. And I have to distribute the negative sign. So over here I'm going to have u plus v minus u plus v when I distribute. This time the u's cancel. So x minus y equals 2 v's. And when I divide by 2, v is equal to x minus y divided by 2. Alright so far. Now what you're going to notice is I purposefully put another slide in here, a blank one, because this was going to take a bit of space. So I'm going to start with a product. The sine of x plus y over 2 times the cosine of x minus y over 2, and just apply the product to sum formula because this is a product and I'm going to turn it into a sum. So remember, that is equal to 1/2 in brackets. The sines, it's going to be two sines, and it's going to be the sum of these plus the difference of those. So inside the brackets, I've got the sine of, open these parentheses, x plus y over 2, that's the first angle, plus x minus y over 2. Plus, now I'm going to do the same thing except for take the difference of the two angles. Sine of x plus y over 2 minus x minus y over 2. Bracket. Keep simplifying this down. Here we go. So bring down my 1/2. Looks like I'm going to run out of time. Stop